we are giving skill trainings. If it is exams, we are giving exam buddy. The session is the second session in series. So we also have a non-IT student helping track that is the begin from basics that is starting tomorrow. So we have a different track for student with high velocity codings, that is for road to code. So we are conducting multiple sessions. So as stated earlier, this is for the academic help for students, the exam buddy series. So today's subjects we are going to deal as CO, computer organization, and the second one, data structures. So Pawan will be starting with data structures, and later on Anisa will join, and she will start the CO subject. So feel free to stop and ask questions. So wherever you have doubts, just type in the chat or unmute and ask. Make sure when you're not talking, you are on mute. And this is a student-to-student knowledge sharing session. So it's nothing from my side or from other trainers. So feel free to interact with the Sandbox Lighthouse team. So just ask questions and get your questions answered. So with that, can I request Divya to take over as moderator and start the session?
Yes, sir. Firstly, good afternoon. My name is Divya Aishwarya and welcome to Sandbox, the place to learn skills for the real world. The motto of Sandbox is to bring the skills gap between academic and industry. In today's section, we are going to learn the concepts of computer organization and the data structures. The speaker, Mr. Anisha, Mr. Pawan from Sandbox came here for data structures knowledge to improve data structures knowledge. And Ms. Anisha from Sandbox came here to improve computer organization knowledge. Okay. Now hand over the section to Mr. Pawan. Pawan, can you?
Yeah. Hi all, this is Pawan. Just a second. Can someone confirm that you are able to see my screen?
Yes, Pawan. It's clear.
Yes, go ahead.
Okay. So, hi, this is Pawan, and I welcome you to the session Data Structures and Algorithm. So basically, let us go into it. So what is an algorithm? So basically, an algorithm is a set of well-defined instructions in a sequence to solve a problem. It shouldn't be something like particularly defined to only a computational one. It can be something like, it can be generally any problem. So let us take a problem of making a lemonade. So our end goal is to make a lemonade. So what exactly the steps that we are going to follow is called as an algorithm. So initially we need a few things like lemon, water, sugar, tumbler, and then we need to squeeze the lemon and then add sugar and then stir it well with the water, and then we can have the lemonade. So these are all the steps to make a lemonade. So these are also called as an algorithm. And each individual step is called as an instruction of an algorithm. So there are different ways to solve a problem. It can be like a complex one. It can be an easy one. There can be different ways. So there are certain parameters to say that an algorithm is good. So there are input and output should be defined precisely. That is, there shouldn't be any kind of ambiguity within like defining the input and output. The output should be clear and the input should also be clear. For this lemonade, we can take the output as lemonade and the input as the initial ones, that is lemon, tumbler, water, and all. So they are defined with certainty. And the second one is each step in the algorithm should be clear and unambiguous. That is, each step should be like, it should be on the way to achieve the end goal, and it should be certain. And the third one is algorithm should be most effective among many different ways to solve a problem. So that is similar to what I told earlier. So there can be many different ways to solve a problem, but the algorithm should be the optimal way. And the fourth one is an algorithm shouldn't include computer code. Instead, the algorithm should be written in such a way that it can be used in different programming languages. That is, the algorithm is the procedure to solve a problem. It shouldn't be dependent on what programming language we're going to use. It should be like the steps and the instructions. It shouldn't be like programming language independent. So let us take an example of an algorithm to add two numbers that are entered by the user. So as you can see, let us take the example of 2 plus 3. So each instruction should be well assigned with the steps and numberings. So as you can see, here we assign the number of the step. So initially, every algorithm should be starting with the start and it should be end with the stop. So as you can see, the first step is start and the last step is stop. And the second step is we need to declare like what are the variables we are going to use. And we are using the number one, number two, and sum. Sum is for assigning the result of this. And for step three, we are going to read the values of number one, number two, and fourth step is we need to add these two and assign the result to the sum. And the fifth step is to display the sum. So once again, the algorithm doesn't need to contain pseudocode or code. Okay. So coming to why should we learn data structures and algorithms? Well, these are pretty much required if we wish to secure a job in dream and super dream companies like FANG and other MNCs. And even if you wish to create applications, data structures might be required. And also, these carry a lot of importance in application development, competitive programming, and scalability of applications. Basically, the acronym for FANG is Facebook, Amazon, Apple, Netflix, Google. So it's actually a fancy term that is used in the programming world. What I mean is these are not the only companies that use data structures, but what I'm trying to say is these all the top tech five giants. So what I mean to tell is they create a benchmark. Look, like whatever the way they solve a problem, like whatever the structure they have. Hello.
Yes, Pawan, you're audible. Go ahead.
Okay. So what I'm trying to say is these are the benchmark companies. It doesn't mean that you should go only for these companies, but these are all the top five tech giants. So they keep a benchmark level, and these are adopted by all other tech companies. So yeah, if you wish to go in a super dream company or a dream company, like all these companies, you should be well versed with the data structures and algorithms. So coming to the point, why do they care about data structures and algorithms? Well, one main parameter of an algorithm is the time it takes to solve a problem and the amount of memory it takes to solve a problem. So, okay, let us take a problem for reference of finding the sum of numbers from 1 to 1 followed by some tens of numbers. So, one classic way to solve this problem is by initiating a variable called sum to 0, as you can see here, and initiating a for loop and adding the value to sum. That is like, one second. Initially, the sum value should be 0, then it should be something like sum plus I. This is sum. So we will initiate a for loop for n, and it will be looping over that. And every time, initially the value of sum will be 0, and I will be 0, then I will be initialized to 1, and then 1 plus 0 is equal to sum is equals to 1, and then I will be initialized to 2, and sum will be 1. So the sum will be assigned to 3. So yeah, like this, we need to iterate over all this big number. So then we can print sum. But yeah, this will definitely solve the problem. But think about the time it takes. Well, time to run a code is equals to the number of instructions into multiplied by time to execute each instruction. So when you calculate that, it takes around 16 minutes. And there is also another way to solve this problem of calculating sum of numbers from 1 to this big number. Well, that is by using this classic formula, that is n into n plus 1 by 2. Well, when you use this n denotes the maximum number that we want to calculate. And well, if you use this formula, when calculated, it just takes around 10 nanoseconds. Well, and also it's just a single instruction. The program will obviously many times faster than the previous one. So think this way, that calculating a number itself is having such a huge difference of execution time. Like 16 minutes is very large when compared to the 10 nanoseconds. But think in this way, but these take days all the time, that is 24 by 7 by 365 days. They deal with the petaflops of data. So how much optimization they require and how much efficient algorithms they require. And that is why they choose people with excellent programming skills with respect to data structures and algorithms. And the thing is, memory is expansive and scalability is pretty important. Okay, memory is expansive. Just take the case of pen drives. Like the price of a 16 GB pen drive would be something near 300 to 400, and the price of a 64 GB pen drive would be something around 1000 to 1200. So it's something like 300 was 1200, and here it is 16 GB was 64 GB. So almost it's 4 times. That is, just for the difference of such a small amount of memory, if it is 4 times, think about the petaflops of data that they need to store and process. And that is why data structures and algorithms are pretty important. All they think about during the hiring is how many man hours can this candidate can save and how much processing power and computing power can this candidate save. And they hire programmers who are exceptionally good at optimizing algorithms. So yeah, this is the introduction for data structures and algorithms. Any doubts so far?
Do we have any questions for Pawan so far?
Okay, sir, I'll continue then.
So let me check with Divya also. She is the main moderator, right?
Sure.
Tell me.
Okay.
Okay. So, well, this is the introduction for data structures and algorithms. Coming to the next thing is asymptotic analysis. So, yeah. The thing is, the time and the space that an algorithm takes is described by the asymptotic analysis. So, just a second. Okay. So think about a problem X, and we say that it takes something around 15 minutes to solve. When using something like 2 GB RAM and the processor should be something around 2016 or 2014 upgrade. But when you take an NVIDIA graphic card and all that processing unit, it should take something around like it can be done around something like 6 to 7 minutes. So we cannot say that it should be the algorithm and the asymptotic analysis should be independent of the processing power or the components that we use. So we need a notation, like general notation, independent of the architecture that we use. So that is why asymptotic analysis is used. So for better understanding, let us take an element, like finding an element in an array. So let us presume that this is an array and there are different elements, 6, 7, 8, 9, 10. So we need to find the element 9. So consider it as a list for better understanding. So in Python, if you define a list with these numbers, if you use a search method, what it does is it will be traversing through all these lists. Like it will be initialized to the first element, and then it will go to the second element, and then it will check. It checks all these elements. So if you like an algorithm can be described in its worst, best, and the average case. So for us, the average case, for us, the best case should be like if the required element itself, if our required element is 9, if our required element is itself in first position, so the algorithm shouldn't require to all it should traverse all these remaining elements, right? It can be found at the very initial stage. So we can take this as the best case. And for the final case, that is 10. If the number 9 is in the position of number 10, then the algorithm should process to traverse through all these elements, and it need to find the required element, and that is in the last position. So it is the worst case. And the average case be like something in between the worst and the best case. And these are actually called as the best, worst, and the average cases. And these are also called as 1 second. These are also denoted as big O, theta, and omega notations. This is the big O notation. That is, this is called the worst case. And this is called the big O, and this is called as uh, this is theta, and this is omega. Omega is the best case, this is the worst case, and this is the average case. Think this as a algorithmic way. Like f of n is our required solution, and c1 of g of n is the worst case. Sorry, best case, and c2 g of n is the worst case. And this should be with respect to time. So the best case obviously will take the less time, and the worst case will obviously take the worst time. So f of n should be bounded by the worst case and the best case. I mean to say that the solution should be within these limits, and this is what is called as asymptotic analysis. And generally, for any problem, we'll take the worst case. That is worst possible scenario. Okay. So yeah, this is asymptotic analysis. Any doubts so far? Okay, I'll continue.
Divya, any doubts so far?
No, sir. Let him continue.
Yeah, some other person wants to ask something.
Yes, sir.
I heard someone unmuting and talking.
I got a message. Okay.
Any questions so far, students? Okay, if you have any questions, you can type in the chat also. Okay,
sir, is my voice clear, sir? I mean, without any background disturbance?
Yeah, it's perfect.
Okay, sir. Thank you. So yeah, this is the asymptotic analysis. Well, let us continue with the data structures. Okay. So data structure. Well, data structures is something like a method to define data, like to hold data and to work with the data and also to manipulate the data. So there are different kinds of data structures possible. That is linear data structure, non-linear data structure. Under the linear data structure, you get all these things. And under the non-linear data structures, you will get these things. So what is the basic difference of linear data structure and non-linear data structure? As you can see by the definition itself, is linear is something that is like, it is oriented in a straight way, like either vertical or either a horizontal. Think that way. I mean, non-linear can be divided into subgroups. Okay, for better understanding, let us take one of these. Let us take a static array. So static array should be something like this. The data is held in all these positions. And if you take a tree can be like this. And if you go for a graph, then this can be called as a graph. As you can see, in the linear data structure, a single data point is associated with only one particular data point. I mean, it can be associated with two different points, but all these are linearly arranged. And if you see in the non-linear data structure, if you see the graph or tree, these are not in a linear oriented fashion. So yeah, these are called as non-linear and these are called as linear. Well, you can, under the linear data structure, it can be static and dynamic. Static is something that is predefined, and dynamic is something that is, it can be expanded or compressed as required. So array is predefined generally, and dynamic, you can use a linked list, queue, stack if you doesn't know what will be the exact size that you require. And under the non-linear data structure, you'll be having tree and graph. Okay, then stacks. Well, stack is something like a pile of plates. Like as you can see in earlier, just a second. Yeah, in this is something like a stack. So you can take this. So let us name these things. It should be 1, it should be 2, it should be 3, 4, 5. So basically, stack follows the principle of last in, first out. That is, the 5 element is added at last, and it can be taken out at first. If you want to take out the element 3, you cannot directly do. You need to remove 5, 4, and then you can remove 3. And if you add something in the middle, you cannot do that. You can only add at the top. And that is what is called as last in, first out. So yeah, the possible operations is pop, push, is empty, is full, top. So what this represent? Pop is something like a deleting element. Pop is something like removing an element. Push is something like an adding element. And is empty, is full denotes, it actually returns a Boolean value. Boolean value means true or false. Is empty is something if it returns true if the stack is empty, and is full is something if the stack is full, then it will return true. And top, it can be also called as peak. And what it does is it returns the topmost element, that is the highest element. Yep. Okay, let us take this working. So at first we have initialized an empty stack, then we pushed number 1, then we push number 2, then we push number 3, and if we apply the operation pop, only the upper element will be taken out. So yeah, and it should be something like written like this: 1 and 2. Okay. So basically, while initializing empty stack, what we do is we initialize a pointer called top, and that should be initialized with -1. So whenever an element is pushed, that is added to the empty stack, then it should be like incremented by +1. Okay. Basically, and top is a pointer. So stack time complexity, as I've said, time complexities are pretty much required. And the stack time complexity is something. Guess what? It's just single 1. So why it is 1? Why it is a constant? Because for pop or push, you don't traverse all these elements, right? You only go with the topmost element. That is, even if you pushed, it should be something like a topmost element, and even if you pop, it should be like topmost element. So the time complexity is something like O of 1. That is a constant time. So applications, do undo. Let me give you something. Think this, and if we press Ctrl Z, it should disappear. And this is an application, best application of stack. And as you can see, if you go to some website and if you navigate to some URL and if you press backward, it should return you the previous page. And that is also an application of a stack. And expression evaluation, prefix, postfix. Let us take an expression. So basically, we know how to do this by using BODMAS rule, but basically, the thing is, computer cannot understand the BODMAS rule. It should only understand in a mathematical way. So the prefix and postfix, that is like, we can solve this problem. The computer can solve this problem using stacks. So the other data structure, that is queue. Stack, queue. Yeah, queue. As you can see, stacks follow last in, first out, but queue is something different, something pretty different. And it follows the principle of first in, first out principle. Okay, for better understanding, let us take an example of a railway queue system. So let us assume this is the counter and we have people here and this is me. So if I want to buy a ticket, I cannot fight with all these people and buy a ticket, right? I need to, like the line should be compressed. I mean, the people should buy the ticket and they need to go, and I can come to this position. So I cannot traverse. I mean, like I cannot push all these people and go directly. So I need to wait and I need to go. What the thing happening is, this is the counter. So if I'm adding to the line, like if there is another customer, he should be added somewhere here. He cannot be added somewhere here. If he does, then people will beat him. So obviously he should be added at the end. So basically, this is the first guy to appear in the queue. So he will take the ticket, he will take the first ticket and he will go. This is something like first in, first out. And yes, queue follows this principle. Okay, let us take the working of queue and let us initialize an empty queue. Then the thing is, in queues, what we do is there are different, the pop is called as NQ and the push is called as DQ with respect to queues. And all these other operations are similar. This returns a Boolean value, this returns a Boolean value, and this returns the topmost element. So basically what it does is, like at start we initialize 2 pointers, that is front and rear pointers to -1. Okay, let us see this. So this is an empty queue. If you enqueue something, it is being added. I'm sorry, these are returned reverse order. My bad. Okay, if you add something, that is enqueue, and if you remove something, that is DQ. Okay, enqueue is something like a push, and DQ is something like pop. So okay, working of it. So basically, at the initialization of a queue itself, we will define 2 different pointers, and we'll be initializing both of them to -1. So this initial stage -1, front and rear, both these pointers will be initialized to -1. If you add something, then the front and rear point will be incremented by +1. So yeah, here. So we enqueued the first element, that is push the first element, and that is 1. We enqueued the second element. Whenever if it is in empty stack, then if we push an element, both the front and rear pointers will be added by 1. But if it is a queue with some element, like it can be like 1 element or it can be some 10 elements, it doesn't matter. If it is not an empty queue, then only the rear pointer is added +1. So as you can see, an element is added 1. So initially it is empty, so an element added 1. So both these front and rear pointers are incremented by 1. But when you add, only the rear pointer will be traversed by 1 and the element is added. And the front pointer will be there with the first element itself. So you'll be adding all these elements. And then what happens is, if you DQ, that is, if you remove an element, that is pop. If you pop an element, the DQ pointer will be added by +1. So yeah, 1 is gone. Now the front pointer is pointing towards 2, but the rear element will be there itself. So what I mean to say is, during empty queue, both of them will be added by +1, but during NQ, only the rear pointer will be added by 1, and during DQ, only the front pointer will be added by 1. So yeah, DQ, the last element. So again, we'll be having the empty queue. As I said, if it is empty queue, both of them should be -1. So limitation of queue. So basically what happening is, if you take this, 1, 2, 3. So initially they were there. And what we've done is, if we NQ, then if we added three elements, and then if we remove the first element, the front pointer should be here and the rear pointer should be here. So basically, removing is not mean like we are not deleting it from the system memory. It is something that the pointer is being shifted. Like the 1 will rest in that memory address only, but the pointer will be shifted to 2. Did you get my point? I mean to say that the 1 will not go anywhere. It should be there, but the pointers will be changing its positions. So yeah, if we do that, if there are some 100 elements and we keep on going with NQ and DQ. And we may lose all these front space, right? Even now, the one is in that initial position only, but we are losing this memory position. So yeah, that consumes more space if it is not reset to the initial position. So that is a limitation of a queue. So there are certain other techniques like advanced queues where this limitation is solved. So complexity analysis, as I said, push and pop. You're not traversing through all elements, right? You're just focusing on these pointers, and these pointers will only take a step, right? One step at a time. That is one step at a time. So it is not going. This front is not going all these points at a time, right? It's just traveling like a single step. So the complexity analysis should be constant. That is one for NQ and DQ. And applications, CPU scheduling, disk scheduling, queuing system. So any doubts?
Any doubts so far?
No, sir.
Okay, I'll go with the next one. That is, as I said, this limitation is solved in much advanced queues. That is, we have different queues. That is simple queue, circular queue, double-ended queue. There can be some n number of queues, and you don't need to learn and know about all of them because they are not required. Basically, these are the main important things. And if you know these three of them, then you are giving a tool to build whatever you want as per your requirements. So we need to focus on only these three things. So simple queue. This is an implementation of a linked list. So what is a linked list? I'll just tell you briefly. So assume this as this contains two spaces and it is called as a node, and a group of nodes with some relation is can be called as a linked list. So what does a node contain? It contains information here. One particular part contains information and one particular part contains a memory address. The thing is, it doesn't contain the memory of address of this node. It contains the memory address of the previous or the next node. That is, it should point towards the next node or it should point towards the previous node. So okay, this is a as I just need you to know that this is a implementation of a linked list for queue. So here we can have the memory addresses. As you can see, this is a point where it contains the memory address of this node, and this should contain the memory address of this node. And here we can have the data. It can be something X value, Y value, Z value. So yes, this is a simple implementation of a queue. Simple queue is nothing than a queue. It can have all these things. Next is a circular queue. As I said, so we have different elements in all these boxes, and if we pop, this element should be there, but the pointer is iterated with +1. So we are losing this memory. So one thing is we can use the circular queue. So as in the circular queue, it points towards the initial node. This is the implementation of a circular queue. And that is the last node contains the memory address of the first node. That is, if you come to this, if you traverse for a circular queue, if you come to this particular position, then you should return with this particular position. And that is circular queue and double-ended queue. As I've said, the thing is, for a simple queue, the insertion and deletion takes at different places. But double-ended queue, you can have the insertion and deletion at both ends. But as in a simple queue, you can have only one at one end. See, here you cannot delete a thing, and here you cannot insert a thing. So that is double-ended queue. Okay, these are all the data structures. Due to the factor of time concern, I've took only the two data structures. If there is a session, I can continue with the rest of them. So let us go to the sorting and searching. Sorting and searching is also pretty important. Let us say that you will be visiting a website of Netflix, and you need to find something like a movie. So Netflix contains some thousands of movies, and you need to find one particular movie. So searching is pretty important there, right? Without searching, you cannot go. It would take a lot of time, but with the help of searching, you can actually get the result at very small time. So that is why searching is pretty important. And sorting is also pretty required in terms of analysis, like algorithmic analysis. Okay, so there are different kinds of sorts. I think it should be around something like 15 to 20 different types of sorts. And for search, I know only two. So the main I picked only the two important sorts and two important search. So the first one I took is bubble sort. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in a wrong order. So basically, you can take this. The algorithm will contain like this logic. Like swapping the values of two elements. Take this example of 51428. So as I said, wrong order. Wrong order means let me do something. What wrong order denotes means this is a wrong order because 5 is greater than and 1 is less than 5. So I mean to say it should be in an ascending order or descending order. We'll be taking ascending order here. So this is a wrong order. So what it does is if you take 51428, then 5 is greater than 1 and it should be beyond 1. I don't care about the rest of the positions because the algorithm doesn't care. So why should we care? So basically, it takes only two elements at a time. So we'll be concentrating on the first two elements, that is 5 and 1. And 5 is greater than 1, and 1 should be before 5, and 5 should be beyond 1. So what it does is swap. It doesn't basically know about the rest of the things until it traversed. So here the algorithm compares the first two elements and swaps 5, 1. So we'll be getting this result 1, 5, 4, 2, 8. So next, it travels to one element. Now it will be taking the next two elements, that is 5, 4. So yeah, here it is in a wrong order. So it should swap. Then we'll be getting this result 1, 4, 5, 2. 2 is smaller than 5, so it should swap. We'll be getting this 1, 4, 2, 5, 8. This is fine. This thing is fine. Uh, the algorithm has traversed to all elements, but as you can see, 2 is still less than 4. And yeah, so this is wrong, but it has traversed one pass. This is called as a pass. So if in examination terms, if they ask you about they will be giving you an array and they will be asking you to write the implementation of bubble sort or the technique of bubble sort, and you can do this thing. The main aim is the algorithm needs one whole pass without any swap to know it is sorted. As I've told, it only compares two elements at a time, and it doesn't have the memory of knowing all other elements. So the algorithm needs one whole pass. But as you can see, it hasn't passed. I mean, what does a whole pass means? From the starting element to the end element, it should pass without any swapping. That is mean by whole pass. If you do that recursively, then you should be like, again, it will be, this is the first pass. Pass here represents like it started with 1 and ended with some last number. So the second pass, it again starts with 1. So again, 1, 4, this is okay. Then again, 4, 2, 4, 2 is an issue. So 2 will be a jump to front and 4 will be to back. And then we'll be having this is fine, this is fine, this is fine. Yes, now we got the answer. But as I've said, the algorithms needs one whole pass without any swap to know it is sorted. So again, what it does is traverse to all these elements and it will check. So there is no, as you can see, there is no swap. And yeah, it passed to all these elements and sort is completed. So yeah, time complexity is O of n square. Why O of n square? Because we're using two particular loops, and so that is O of n square. When you write algorithm or code, you can get to know that. And merge sort. If you are familiar with the algorithms, you'll be or design and analysis of algorithms, you'll be coming across divide and conquer technique, like divide and conquer, greedy algorithms. All these will come for you in due time. And divide and conquer is one such technique that is widely used in computational world. So this is also a kind of sort. Any sort needs to be the main basic aim of a sort is to sort the things. So let us take an example. We have 6, 8, 10, 1, 54, 7, 61. So what it does is it takes the floor or seal value of the array. Like if we say the size of this thing is n by 2, that if we get something in decimals, it should take something of a floor value. Floor value means if 3.7 is there, it should be going with 3. That is called as floor value. So we don't have a problem here. I think 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it can be evenly divided. So what? Just see the implementation of method. Method takes the middlemost position that is here, and it divides into two such things. We'll be having 6, 8, 10, 1, 54, 7, 61. We have two different arrays. Now what it does is it further divides. Like it again divides to 6, 8, and 10, 1, and 54, and 7, 61. And it again divides to 6, 8. It divides until it all those are independent arrays. As you can see, these there are two arrays here. There is one array, but here everything is divided into an independent array. So you will be getting the number of arrays will be equal to the number of elements. So similarly, you will get all these points. And what it does is, one second, some issue. So you will be having independent elements. Now what it does is it will take two elements and it will sort. Like you have 6 and 8 as independent arrays, but during the combination, like here, it will be again added to the one thing. So there are 8, right? If two are combining to one particular array, then there will be 4 arrays. We'll be having 6, 8, 10, 1 as one array, 54 as one array, 761 as one array. What it does is during this particular moment, it will check with the two values. And if there is any difference in the order, the values will be jumped. So we have 6 and 8, that is okay. We have 10, 1, 10, 1, and 10 and 1 is an issue. So 1 is a smaller element and 10 is a bigger element. So 1 will be jumped to this position and 10 will be jumped to this position. We'll be having 1 here, 10 here. So for 54, 50 is a very big element when compared to 4. So we'll be having 4 here, 50 here. And 761, it is fine. Okay, now the 4 will be again merged to 2. So now it checks within all these elements. And now if it checks, 1 is a very small element, so it should be jumped to here. 6 should be here. 8 should be here. 10 should be here. And again here, 4 should be here, 7 should be here, 50 should be here, 61 should be here. And again, it will merge both these into one particular thing and it should be in order. And again, it will check with each element and it should be ordered. The thing is, basically, this is a type of implementation of divide and conquer. And as you can even tree is also a method. I mean, trees use a technique of divide and conquer. What it does is, like in bubble sort, a single processing unit is like working on all these instructions, all these techniques. But in merge sort, the thing is, the problem is divided to the smallest possible representation that is here. And like each different processing unit is working on this. And the complexity, if you take the in terms of complexity, when you divide a thing and work on it, the complexity should be something like log of n. And during the combination, it takes n time complexity, so it is n log of n. And merge sort is n log of n. Remember, n value is greater than log of n. So if you see this bubble sort, the complexity is of n squared, that is n into n. But whereas in merge sort, it should be n log n. And as I said, n is greater than log n. So this is the better thing than bubble sort. So merge sort is better than bubble sort. Yes, this is the implementation of merge sort. So let us go with the other two search techniques. Linear search is the simplest searching algorithm that searches for an element in in the list of sequential order. So let us assume that we need element 7. So what does a linear search do? Linear search point goes with the first element. It checks if it is equal to the required element is 7. It checks 7 is equals to 6. No, then it will be passing on to the next element. 8, it is not equal. Then it will be passing on to the next element. It goes on traversing like each element. And until it's found, it will be traversing all this. So what is the time complexity? As I said, this is big O representation. That is worst case. The worst possible case is if the element is in the last order. So the worst possible case is O of n. That is, if the required element is in the last position. So this is the implementation of linear search. It's pretty easy. If you want to implement in code, you can iterate over a for loop for the range of all elements, like the number of elements, and you can like if the required element is assigned to x, you can use this logic and you can write the code for linear search. The next thing, and like binary search has an edge over linear search, and binary search is a searching algorithm for finding an element's position in a sorted array. In this approach, the element is always searched in the middle of the portion of an array. So basically, what it means is, just a second. Yeah. So one thing we need to remember here is binary search can be implemented only on a sorted list of items. If the elements are not sorted already, we need to first sort them using any of these techniques. It shouldn't be like it can be any other sorting techniques apart from bubble sort or merge sort. So here, as you can see, I've taken example of I've taken an example of a sorted array. So let us assume that the required element is 10, that we need to 10, we need the value of 10 and we need to know its position. So what it does is, this is the implementation. So it will take this as the first and this will take as the last element. So what it does is, so the required element is 10. So it will, let us assume this, the size of it is n, and it will be divided by 2, and the value should be something like floor value. And it checks with the like, see, we'll be getting the middle element, right? It will check with the middle element, and if it is equal to the middle element, then it is good. If not equals to the middle element, then the end position will be, if you can see the here, the middle element is 14. It checks 10 with the 14, but 14 is pretty greater than 10. So what it does is it points the like final pointer to the n by 2 minus 1 position, that is 12. So now again, n by 2, it does again n by 2, that is the now the size is 3 and by 2 it's 1. So uh, see, the middle element is something like 10. So it will 10 is equals to 10 and it returns the value of 10. I mean the position of 10. and this is the implementation of binary search. Any questions?
Hi guys. Can anyone ask any questions and have any doubts?
So once again, the thing is, if you want to like aim for something like a pretty good companies, you see that they are pretty good when compared to the rest of the companies. And I don't mean to say only those five companies. I mean like good companies basically. So all these take. I mean not only these, even the like unicorn startups. They consider people with efficient knowledge of data structures and algorithms, because they always deal with the data of such a large amount, and handling data is not pretty easy, and it's not something like like optimal. It requires a lot of money investment, a lot of efficiency, a lot of computation power. So all they do is pick they only hire candidates who can optimize these things. Like if they can scale something like 1,000 GB to at least let me say something like 500 GB or 400 GB, that is something pretty good, right? They at least divided the problem by half. So that is what these companies require. So if you aim for these particular companies, it's better to start coding, like working about data structures and algorithms. So basically, you don't need to hard code all of these algorithms. You just need to know the implementation. And even for these companies, like if you go for the technical round, they doesn't ask you to implement a B tree or B plus tree or AVL tree, not something like that, but they give something a different problem, a unique problem, but that involves the like a knowledge of a data structure, they don't ask you to implement this particular problem in using stack or queue, but they ask something like, yeah, you need to solve this particular problem with this computing efficiency and this particular time complexity. So you need to build a solution that should like the basic thing is you can use data structures, and they only give problems that require the use of data structures and algorithms. So what I mean to say is, if you are aiming for such a type of company, or if you are aiming like you are targeting for such things, so then it's better to start practicing in some like online, or you can go for hackathon or lead code, or like I mean to say is start practicing from now, and that is all. Any questions?
Guys, let me know if anyone had any questions.
And remember, again, I'm telling you, you don't need to hard code and like by heart every single line of code. You just need to know how those are implemented, like different type of techniques, and you need to understand the complexity analysis. That is pretty important. Even if you go for interview, let me tell you something. Like if you pass, if you pass it a few technical rounds, if you are going for a technical interview, they will be asking you to implement an algorithm, or I can say if they'll give you a problem and they'll ask you to hard code for that, and they will be giving you a piece of paper and pen, and they can even give you a laptop and big whiteboard. You can pick whatever tool you want. You can write the code and you can show them. Even if it's in paper, it's fine. You don't need to actually code in a programming computer. Like you don't need to show that. You can hard code even in the paper. And if you pick they can ask you a question like, so what is the time complexity for this algorithm that you made? And they can even ask you like, try to reduce the time complexity. So time complexity is pretty important. And yeah.
Okay, guys. Anyone had any doubts? Just clarify now itself.
Jani
Let
sir,
me
if
continue
there
with
isn't
the next
any,
section.
I can
Yes,
go.
Pawan.
I can take a break, sir. I mean, if there is
Okay,
no other question.
sure. Thanks, Pawan. Thanks for delivering 1 hour session. It was very much interactive and understandable. Thank you.
Okay, sir. Thank you.
Thank you, Pawan. Thank you for your support. Okay, Preeti, can you handle the section? according to computer organization. Preeti, are you hearing me? Preeti, are you hearing me?
So you want Preeti to moderate, Divya?
Yeah, sir. Let her continue. It's 3.
Yeah, Anisa will be delivering the CO session, right? Anisa, am I audible to you?
Yes, sir. Audible, sir. Sir?
Yeah, please check with Preeti also if she's audible. Okay, so some microphone issue with Preeti. So Divya, would you like to continue till Preeti resolves the issue?
Hi, Anisha. Hi, Anisha. I'm here. Are you hear me?
Yes, I am. Yes, it's audible.
Yeah. Now start.
Okay. Screen is visible.
It's
Hello.
visible. Yeah, Anisha, it's visible. Now continue.
Okay. Hello. Good afternoon, everyone. Today, I'm discuss something about computer organization. Firstly, we will know what is meant by computer organization. Okay. The computer organization is nothing but the functional units and their interconnections. How the functional units are to be interconnected with each other. It can be specified by the computer organization. Okay. Then the functional units. What are the functional units we are having? There are basically 5 types of functional units. That is input, output, CPU, and memory. CPU is nothing but a brain, brain of a computer. So CPU consists of control unit and as well as arithmetic and logic unit. Both can be combined. Then it is called as CPU. Okay, input unit. What is meant by input unit? Input unit is nothing but um, input. Whatever the data is to be given by the user, then it can be taken by the input. For example, input devices like keyboard, mouse, scanner, joystick, trackballs, all are those are input devices. So, whatever the data that, for example, whenever a user key is pressed, then it can be taken by the memory unit or it can be taken by the arithmetic logical unit. If the user can press 2 plus 3, then it can be goes to the arithmetic logic unit. It means arithmetic logic unit consists of arithmetic operation like addition, subtraction, multiplication, division, all those things. So if user can press any key, then it goes to the arithmetic logic unit, then it performs the operation, then it sends to the output unit. That can be visible by the user. That can be seen by the user in the form of monitor. There is what we call output devices are monitor everything we can see, and it is called output devices. Okay. Next, memory unit. What is the main purpose of memory unit? The memory unit is can be used for storing the data or retrieving the data. For all those things we can use the memory. Okay, there are 2 types of memories: primary memory and secondary memory. Primary memory we can use for the small amount of data. For that purpose, we can use primary memory, like random access memory. The primary memory or random access memory. Okay, in the primary memory, the address can be stored in the form of bits. The word length is nothing but the number of bits in each word is called a word length. Each a word consists of 32 bits. A byte consists of 8 bits. And okay, next, addresses can be stored in the form of memory locations. Okay, the time can be required to access one word is called memory access time. Memory access time. Okay, the secondary memory. The secondary memory actually we in the second primary memory is for storing small amount of data, but in secondary memory we can store large amount of data. But we can read only, but we can't write anything under it because like ROM, CD-ROMs, magnetic disk, optical disk, all those things are secondary memories. Okay, then we can discuss about arithmetic logical unit. It performs arithmetic and logical operations, like addition, subtraction, everything it can perform. And the output unit or actual output unit, it can be sent. It is actually are the counterparts of the input unit. Its basic function is to send the process result to the outside world. Like if the output units like printers, speakers, monitors, etc. Everything. The function of control unit is it is acts as a nerve center that sends signals to other units. It, the actual timing signals it can that govern the transfer of between input unit, processor, memory, output unit, everything it can see by a control unit is that, but it can control all the ports, like input, output, memory, ALU, all the ports can be controlled by the control unit. Okay, this is called single bus structure. What is meant by bus? Everyone thinks that the bus is nothing but a transporting. Bus is actually for transporting from one place to another place. Like the same way in the computer organization also, the bus is nothing but it is a collection of files for transferring the data from one one unit to another unit. Like here we can take single bus. Here the way can take the parts like input, output, memory, and processor. The input it can be sent to the bus. That the bus can input can be gives to the bus, and if the input contains any memory data, like it can give the location of the address, then it goes to the memory and take the specific operand, and it sends to the processor. The processor takes the data and it can process, and then, finally it sends to the output device. Like that, we can use single bus. In this, we only two functional units can perform at a time. Not more than two functional units perform one time. Because why? Because we are using only single bus. In the single bus, we are performing only two. In the single bus, only two functional units can perform the operations. For example, if input and memory can use the bus, then processor and output can't use the bus. Why? Because we are using only one bus. For the purpose, only two functional units can be use the bus. For example, memory and output can use the bus, then input and processors can't use the bus. Here, input is unidirectional. Why? Because your input is nothing but the user can use the input. For the purpose, we can use only one direction. And output is also it can sense to the output devices. So it is also unidirectional. Memory is for bidirectional and processor is bidirectional. Processor is nothing but arithmetic logic unit and control unit. Both are combination called as processor. Okay. For example, if you are if you want to use more than two functional units at a time, we can use two buses. Like we can use multi-bus structure. We can use two buses. At that time, we can perform more than two functional units. Bus is nothing but it is a collection of words to perform. Bus is a collection of words for performing the operations. Okay, next we go to the various bus connects to CPU. Here we can use more three types of buses: data bus, address bus, and control bus. What are what those three things are? Address bus. Address bus carries memory address. A memory address is a numerical value used for identifying a memory location. We are using memory address for identifying the numerical location. Address bus is a unidirectional because data flow in only one direction. From microprocessors to memory or from microprocessors to input or output devices. For the purpose, we are using only unidirectional. The microprocessor consists of 16-bit address bus. 16-bit address bus consists of 16 bits. Nothing but it can address 65,536 different memory locations. Length of the address bus is 16 bits. That is 000H to FFFH. And next is data bus. Data bus is nothing but a group of bytes which carries data only. Address bus it carries only address. The database carry only data. Data bus is a bidirectional and address bus is a unidirectional because only address can perform from CPU to memory or memory to input devices. But data bus can be performed bidirectional. It can flow in both the direction from microprocessors to memory or input devices to output devices and from memory or all input devices to microprocessor. The length of the data bus is 8-bit. It consists of 00H to FFH. Okay. Control bus. Uh, Control bus consists. It is a group of words which is used to generate timing and control signals. Database consists of data, address buses consist of address, and control bus is used for to generate timing and control signals to control the associated peripherals. Here, location like memory read, memory write, IO write, whether memory is can be reading or writing, input and output operations are read or write. For that, we are using control bus for generating timing and control signals to control bus. If one line of control bus may be the read write line. If the wide is low, then the memory is read. If the wide is high, then the memory is written. Here we performing read or write operations in the control bus. The read operations is nothing but if we are using if the wide is low, then the memory is in read operation. If the wide is high, then the memory is written operation. Finally, we'll tell that the address bus is nothing but it can carries the address and it is a 16-bit maximum size is 16-bit. It is a unidirectional. It can store 16 bits of data, that is 00H to FFFH, and the data bus is nothing but it is a group of words. It is carries only data. The data bus is a bidirectional. It consists of 8 bits data, that is 00 to FFH. It can process from input to output or in memory to input devices or input devices to microprocessors. Everything we can perform a data bus. And control bus is nothing but it is a group of words. It can generate timing and the control signals. To controlling all the data, we are using the control bus. In this, some control signals like memory read, memory write, IO write, all those things. IO operations are reading, writing, everything. Then performing with the help of control bus. Types of instructions. There are types of instruction. Instructions is nothing but it is a consist of operators and operands is nothing but an instruction. And there are 3 types of instructions like arithmetic instruction, data transfer instructions, logical instructions. Everyone knows that arithmetic operators like addition, subtraction, or like that only we can perform in instructions is also having addition, subtraction, increment, decrement. All those operators can be required. Okay, now we'll discuss about arithmetic instructions like addition, add. We can use for addition we can use add, or is nothing but register. We can add operations can be used with the help of registers or memory locations. We can use the add operators. Here add or is nothing but we can add the content of the register to the accumulator. Here the opcode is nothing but add and operand is or. Here we can add the content. The register, if the register is having any content, like for example, if we take accumulator is having 10H and register is having 20H, then we can add the registers with the accumulator. It's nothing but 10H plus 20H. Then it is 30H. Then the result can be stored in the accumulator. Performing the operations and the result is also stored in the accumulator. Then we are performing the operations, then we can store the result is also in the accumulator. ADD M is nothing but memory address. We can add the content of memory specified the instruction to the accumulator. We can add the memory address with instruction. For example, in the memory contains 3032H and the accumulator is having 30H. Then we can add, then it is called as 62H. We can store the result is also in the accumulator. Okay. Then ADC. ADC is nothing but add with carry. We can use either here we can use carry also. Here adding the register to the accumulator with previous carry. Okay. The content of the register and the previous are added to the content of the accumulator. For example, if the carry is contain carry flag, First, we'll discuss about flags. We are having carry flag, parity flag, auxiliary carry flag. All flags, all are flags. Here we can use carry flag. If the carry contains 0, then it is nothing but carry flag is not used. If the carry flag is 1, then we can use the carry. And if we use, for example, ADC, add with carry. Here we can add the registers with carry. Add the content, add registers to the accumulated with previous carry. The content of the register and the previous carry is added to the content of the accumulator, and finally the result is stored in the accumulator. For example, accumulator contain 30H and register contain 10H. If the carry flag is set, then the carry is 1. Then we can perform addition operation for those three things, 520H, 32H, and 1. Then it is nothing but a 53H. Then the result is also stored in the accumulator. And then ADCM, add with carry with memory location. Add the content of memory location to the accumulator with previous carry. Here we are adding the memory location, accumulator, and previous carry, and the result is also stored in the accumulator. Okay, ADI. ADI is nothing but add immediate data. Here we can adding the immediate to the accumulator. Immediate data is having 8-bit data. Immediate data is consists of 8-bit data. We can adding the immediate data with the accumulator. The 8-bit data is added to the content of the accumulator, and the result is stored in the accumulator. For example, accumulator consists of 10H and the immediate data is 55H. Then it is nothing but a 65H, and the result is also stored in the accumulator. Okay. SUB. SUB is nothing but subtraction. Subtract the data with registers. Here, the subtract the register from the accumulator. Previously, we will see about addition operations, and now we are seeing about subtractions. The subtractions are like the same. Previously, we'll discuss about addition operation. In the same way, we can perform the subtraction operations also. Here we are using SUB or is nothing but subtract the data of registers with the accumulator, and the result is also stored in the accumulator. Like the same way we are performing the addition, in the same way we are performing the subtraction also. SUBR is nothing but subtract the register from the accumulator. SBBM is nothing but here we can use subtract with borrow. In the previously we are using ADC is nothing but addition with carry. Here we are using subtract with borrow. But subtract with borrow, the subtract the source and borrow from the accumulator. Here we are subtracting memory address with accumulator and borrow. The content of the memory and the borrow flag. Here actually we don't have any borrow flag. We are using carry flag only. If the borrow is nothing but carry flag like that only. If the carry flag is set, then we can perform the borrow operation. If the carry flag is not set, is nothing but 0, then the borrow is not performing any. We can't perform any operations like borrow. Next, increment in INCR. Increment the register memory by 1. Everyone knows that increment operations is nothing but we can increment like 9. If we are incrementing, then it becomes 10. Like that only, we are incrementing the registers and incrementing the memory locations operations also. Here, increment the content of the register by offset. Offset is increment the content of the register by offset. Offset is nothing but for example, if your offset is nothing but 1 or 2 like that, we can use offset also. The content of the designated register are incremented by 1, and the result is stored in the same flag. Like if we are performing increment operation, then the result is also stored in the same register. in the previous way we can perform the operation and the result is stored in the accumulator. Like that only here also we can perform the increment operators and the result is stored in the particular memory. If we are using memory, then the result is stored in the memory. If you are using registers, then the result is stored in the registers. The increment and decrement operators only, and the remaining operators we can store the result in the accumulator. Next, we can see the decrement operator. Decrement operator is nothing but decrementing. For example, if we are having 9, then the by decrementing by 1, then it becomes 8. Like that, we can use a decrement operator. DCCM. DCCM is nothing but we are decre- decrement the content by 1. Like here also we can decrement the operators and we can store whether we can store in the memory locations. If we are using memory, then we can store in the memory location. If we are using register, then we can store in the registers. Now, finally, the arithmetic operators are addition, subtraction, increment, and decrement operators. In the addition and subtraction, operators, we arithmetic instructions, we can store the result in the accumulator, and the increment decrement operators, we can store the result based on the based on the operands like registers or memory. If you are using register, then we can store in the registers. If you are using memory location, then we can store in the memory location. For performing addition and subtraction, all the carry flags are set by using the arithmetic operations is basically perform the arithmetic operations like addition, subtractions. For this purpose only we are using the arithmetic operation. Basically, everyone perform the operations by hands like 2 plus 3 is equals to 5, but the computer don't know whether we can they perform how. For that purpose, we are using these registers, accumulators, memory locations, everything for that purpose only we are using. For the computer knows that we are stored in the memory, then it can fetch the instructions from the memory and it can add. If the content is in the register, then it can fetch the instructions and it can store the instructions to the memory. For that purpose, we are using accumulators, registers, and memory. And next, we are using data transfer instruction. Data transfer instruction. Data transfer instruction is basically used for the ability to move data either between registers or between register and storage location in data transfer also.
Anisha, before you move to data transfer instructions, so can Priti Akanksha and check with students if they are fine till now? There are any questions so far?
From my side, it's clear, sir.
Okay, so Priti also, is your audio clear now?
Yes, sir. Yes, sir. Now it's
Can you check with students if everyone is clear?
Hi, team. Do anyone has any problem till now? Anyone? You can write in chat also. All fine, sir. You can go on, Anisha.
Okay. Okay, now we are using data transfer instructions. The data transfer functions provide the ability to move data either between registers or between register and storage locations in memory. The data transfer instructions are move, load, store, push, pop, in, out. Move is nothing but we are moving the data from one place to another place. Loading is nothing but we are loading the data into the memory or registers and storing the data. Pushing is nothing but we can push the data and push and pop here we are using the form of stacks. If we are pushing the data, it means loading the data, then we are using push operations, pop operations, in and out operations. Okay, one by one we are discussing move operation. The move is nothing but here we are using destinations and source. The destination here the copy from the source to the destination. Moving is nothing but we can copy from source to the destination. For example, we can take R1 as a source and R2 as a destination. Then the data can be moved from source to destination. No, here R1 is source and R2 is destination. Then the data can be moved from source to destination. Then the data finally stores in the destination. Then the R2 contains the data. Then we can use memory locations also here. If we are performing more operations from memory to memory, then we can provide source and destination memory locations and then perform. MVI is nothing but more immediate data, immediate 8-bit data. The 8-bit data is stored in the destination register or memory. Here we are using immediate data. Data is nothing but we can use normal data. We can't use any registers or memory location. We can use 55H or nothing or 10H like that. Data is nothing but immediate data. We are moving the immediate data to the registers or memory. And LDA is nothing but load the accumulator. LDA-M. Here we are the content of the memory location specified by 16-bit address in the operand or copied to the accumulator. Here the data can be copied to the accumulator, like the same way addition and subtraction operation we are storing the result in the accumulator. In the same way we are loading the data to the accumulator. And STA is nothing but store the data in the accumulator. The content of the accumulator are copied into memory location specified by the operand. Here we can store the data like 30H to the accumulator. Then we can here source is a 35 and destination is accumulator. Then we can store the data from 30H to accumulator. And push operation, push the content of the memory location onto the stack. Here everything the move, load, store operations are performed by registers and memory locations. Here push operation is performed by the stack is also nothing but memory only. In the memory we can perform the stack operations, like we are pushing the addresses like that. Push the content of the memory location onto the stack. Here we are using push M. M is we can use memory location or registers. We can, for example, if we use memory location, then the content of memory location in the operand are copied into the stack to the following sequence. Here we are copied the data from memory location to the some specific address. And pop is nothing but we can remove in the data. Stack actually follows last in first out fashion. Where which element it can be stacked first, the element can be popped by the last. It can be removed by the last. Pop operation is for the content of the memory location pointed out by the stack pointer register or copied to the specific memory location. And next we can use out is nothing but output. In is nothing but an input. Output the data from accumulator to a port with 8-bit address. The content of the accumulator are copied into the IO port specified by the operand. Out data transfer instruction is actually used for example we are saying the results, outputs, everything it can be performed with out operation. If the data can if you want to see the data, then the out operation can be performed. And in operation, input data to accumulator from a port with 8-bit address. The content of the input port in the operand are read and loaded into the accumulator. Input is what we can loading the data or reading the data. Everything is can be taken by the input operand. And next we move to the logical instructions. Logical instructions is logical instructions. Actually, we know logical operators like logical AND, logical OR, logical NOT, XOR. AND is nothing but both source and destination. If one, then one. If one of the operand is 1 or 0, then it is 0. 0 and 1, 0. 0, 0, 0. That are performing the AND operation. OR operation is nothing but any one operand is 1, then it is true. Like 1 0 1 0 1 1 0 0. If both are zeros, then only it is 0. Otherwise, every time it is 1. It is fully opposite to AND operation. NOT is nothing but if complement. And XOR operation everything, complement operations, all are on logical instructions. Logical instructions basically perform the basic logical operations like and, or, etc. It can combine two input bits to produce a single output bit. Like that, if we are using 3 and 2, if we are performing 3 and 2, like 3 is nothing but 0 1 1 and 2 is nothing but 0 1 0. If we are performing addition operation, then it we get the result like 0 1 0. It's nothing but 2. It is having command two input bit to produce a single output bit. Okay, we can see first operation like compare. Compare the register with the accumulator. Here we are taking the opcode as compare and operand as or. We can compare the register with the accumulator. Content of the operand compared with the content of the accumulator, then some flags can be triggered. If for example, if one operand is less here, some flags are can be triggered like carry flag, zero flag, and in a compare operation only two flags can be affected like carry flag and zero flag. When carry flag is set and zero flag is reset is nothing but whenever the in compare operation we only carry flag and zero flag can be affected. And next we can go to CPI. CPI is nothing but compare immediate data with the accumulator. Here immediate data is nothing but 8-bit data. Always we can remember immediate data is nothing but a 8-bit data. The second byte data is compared with the content of the accumulator. Here second byte is nothing but a one byte consists of 8 bits. So we can compare the second byte of the data to the accumulator. Here also some flags are to be affected like carry flag, zero flag. For example, if, comparing the immediate data. Okay. If we are comparing the memory immediate data. Okay. Sorry. If in comparing the data also we can use registers or memory. If we are performing any operations like comparing two data, like accumulator data. If accumulator data is consist of 50H and the register data is consist of 30H, then it's nothing but the accumulator data is high compared to the registered data. At that time, accumulated data is high compared to registered data. At that time, carry flag and zero flag are reset. Both the flags are reset. If accumulated data is equal to the registered data, then zero flag is set and carry flag is reset. If accumulated data is less than the register or memory, then carry flag is set, zero flag is reset. Here the main motive is if the accumulated less than, equal or greater than. We are comparing. No, comparing the operations we are using less than, greater than or equal operations. Here accumulated data is less than register or memory, then carry flag is set. Otherwise, if accumulated data is equal to register, then carry flag is reset. If accumulated data is greater than register, then carry flag is reset. In both the cases, equal and greater, carry flag is reset, and less than, carry flag is set. And next, ANA. ANA is nothing but AND operations. Here, logical AND register with the accumulator. ANA OR is nothing but we are using register. Here, the content of the accumulator are logically ANDed with the content of the register. And then result is actually placed in the accumulator. And the operation is nothing but we are logically ANDed with registers and accumulator data and register data. Accumulator data like 10H and register data is 20H. We can AND operation performing if and finally the result is also stored in the accumulator. And next, ANAM. ANAM is nothing but logical and memory with accumulator. The content of the accumulator are logically ANDed with the content of memory, and the result is placed in the memory. Next, we can use ANI. ANI is nothing but logically ANDed immediate data with the accumulator. And XOR. XOR is nothing but exclusively OR operation. OR operation is nothing but any one, for example, OR contains 0. If any one operand is 1, then it can be set. Otherwise, it can be 0, true or false. XOR operation exclusively OR with the memory with the accumulator. The content of the accumulator exclusively OR with the content of memory, and the result is placed in the memory. Here, OR operation and AND operation, the result is stored in the accumulator. XRAM. XRAM is nothing but we can exclusively OR with accumulated data and memory address, and finally the result is stored in the accumulator. XRAR is nothing but XRA or XRAM. ORA. ORA is nothing but logical OR. That is exclusively OR. There is some mistake. Actually, XR is nothing but exclusively OR. That is XOR operation. Or OR is nothing but OR operation. Here, the logical OR register with the accumulator. The content of the accumulator or logically OR with the content of the register, and the result is stored in the accumulator. ORAM, the content of the memory and the accumulator, and the result is stored in the accumulator. We can use complement also. Complement with accumulator, complement with carry, all the logical instructions only. The complement accumulator is nothing but the content of the accumulator or complementer. While complementing, no flags are affected. While comparing, carry flag and flag are affected. While complementing, no flags are affected. CMC is for complement with carry. The carry flag is complemented. No other flags are affected. Here only carry flag is affected. And then the remaining flags are not affected.
Hello? Yes, Anisha.
Yes.
Anisha, wait a moment. Is there any issue, guys? Is there any problem you want to ask to Anisha? Any doubts? Any doubts, guys? Okay, Anisha. Okay, continue. You can ask for hello. Anisha, you can ask for the doubts in between.
Okay.
Okay.
Yeah, Nisha, let's move on. The topic. Let's topic.
Okay. The next topic is hard disk. Actually, why we are using primary memory here? The main motive is memory. The primary memory is for storing the small amount of data. If we are store large amount of data, then the primary memory is not efficient. At that time, we are using the secondary memory. The secondary memory is consists of hard disk or like optical disk. Everything are consists of in secondary memory. Next, hard disk will store large amount of data compared to primary memory. So for that purpose, we are using the hard disk. In the above diagram, we can see disks and rotatory drive shafts, access mechanism, read or write head. Okay, here disk plates. Here the disk consists of disk plates. Here the disk consists of 3 displays, like 1, 2, 3, and it is having rotatory shift. Whenever user want to read or write the data, then the read and write can be rotated other than disks. Here rotatory shaft. Okay. If you are having in this diagram, we are having 3 disks only. If you are having if you want to have more than 3 disks, then we can also perform. Then we can use more than 3 disks also. Here we are performing read write operations, and we are having rotate shift mechanism. Here the disk plates, all disks are connected to the rotatory shift. Whenever user want to read or write the data, then the read and write drive shaft will help for rotating the data. Mm, for main, this mechanism is only for main for performing for storing the large amount of data. We are using this magnetic hard disk. It is nothing but an organization and accessing of disk. It stores the access nature of the disk. It consists of sectors and tracks. For example, if you are saying the magnetic disk consists of sectors, task, track, and surfaces. All these lines or tracks and sector is nothing but a combination of track for one. For example, here we are using sector 0 and track 0. The first line is sector 0 and track 0. The second line consists of sector 0 and track 1, sector 0 and track 2, like that. This sector we are using the hard disk for to erase the data from the for erasing the data from the disk, or to store the data in the disk to perform the manipulations. This hard disk are mainly used for we can erase the data, or we can store the data, or we can perform manipulations. For all those purposes we are using this hard disk. Here we are using sectors and tracks. Sector 0, track 0, sector 0, track 1. Like that way we can use more than how many sectors we want. We can use that many of sectors and tracks. The combination of sectors and tracks is called surface area. For one sector we are having more than one track. For one surface area we are having more than one sector or more than one track. Like that way we can perform we can access the disk. It's nothing but disk controller. Disk controller is consist of processor, main memory, disk processor and memory. Main memory. It can be connected through the system bus. Processor and main memory can be connected with the system bus to the disk controller. The disk controller consists of disk drives. Here we are using 2 disk drives only. If you want, you can use more than 2 disk drives. Here the disk drives is used for manipulations or storing or erasing the data. For that purpose, we are using this disk drives, and the disk controller is useful for controlling the data, whether it can be perform read operation or write operation, or it is doing any manipulation. For all those things, it can be disk controller can control the data. Well, the disk drives can perform all those data. That data can be controlled by the disk controller. The processor and main memory is used for performing the operations. For process is performing the operation. Main memory is for storing the data, or retrieving the data, or storing, retrieving. For all those things, we are using the main memory, and all those components are connected with the system bus. Okay, the next topic is optical disk. Optical disk is nothing but it is also a one part of hard disk mechanism only. It is also stored large amount of data. For that purpose only we are using the optical disk also. Nowadays optical disk is not using, but it is very efficient. But it is for example, nowadays we are using optical disc in the form of DVDs, CDs, like that. We can using this optical disc. Here we can use the CD technology. Here we can consist of polycarbonate plastic, aluminium, acrylic, label. Here the green color pod. Like here the green color pod is nothing but is having the bottom, and the red color pod is a top. Here the polycarbonate plastic, the top position. Actually, this polycarbonate plastic is a top position, and the red color is a bottom position. Here, the top position, actually, we are seeing in DVDs, the top position is in the form of shining part. In this, we can see our faces also. Is actually the pot is nothing but a polycarbonate plastic. That is not a glass. Actually, it is a polycarbonate plastic. Everyone says that in the DVDs. the top, the bottom side and top side. Here the top side is position consists of all sectors, tracks, all those are performed in top position only. Here the top position is called polycarbonate plastic, and the bottom position is called label. Label is consist of every label is nothing but in the disc. In the DVD we can see the names, like anything like cinema names, everything can be right. No, that type, that is called a label. We can perform that operations in label part, and all the parts can be all the data can be stored in the polycarbonate plastic. Here we can use aluminum. Aluminum is a main part. In the layer of aluminum, in the aluminum part, the actual data is stored. Here, the aluminum part, actually this top and bottom is called pit and land. Pit, the actual data is stored in the form of aluminum. We can take it as a pit and land operation. Land, we can perform operations. And acrylic. Uh, acrylic is used for to strengthen the disc. The last part is a label. Finally, in the civil technology, it consists of only 4 parts: polycarbonate plastic, aluminum, acrylic, and label. Polycarbonate plastic is in the top position. It shows, it look like a shining pot. In this, we can actually everyone sees that it is a shining part. Like we can see our faces also in the top part. For the purpose, actually, that is not a glass. It is a polycarbonate plastic. If for manufacturing we can use polycarbonate plastic. And next is aluminum part. In the aluminum part, the layer of aluminum is the main, because the actual data is stored in the aluminum part only. In the aluminum we can use pit and lands, the top and bottom. Here it can be moved in the top and bottom like that, no. So it is called pit and land. And the acrylic part is for strengthen the disk. Whether the disk is full or it can be stored, how much data, everything it can be show is by the acrylic part. Label part is nothing but it is the bottom part. In the label part we can perform any we can do like in the label part everyone says it can be in the label part it can consist of songs, movie names, everything it can be written in the label part only. Thank you. If you have any queries. Hello?
Yeah, Nisha, it's fine. Guys, do you have any queries? Guys, do you have any queries? Guys, can you hear me?
Any queries, students? I think no.
Let them give 5 minutes.
Sure. And so the high-level topics, can you just revise, Anissa, please? What are the topics you discussed?
We discuss the topics like functional units of a computer, bus structure, and various bus connects to CPU, how the bus connects to CPU, like control bus, address bus, and data bus, and the types of instructions like arithmetic instruction, data transfer instruction, logic instructions. Arithmetic instructions consist of addition, subtraction, add with carry, add with immediate data, subtract with borrow, increment and decrement operations. And data transfer instructions consist of move, load, store, push, pop, out, in, moving the data, loading the data from the accumulator, storing the data to the accumulator, and pushing the data. Pop data out is nothing but output. In is nothing but input the data. Out is nothing but output. We can perform the output operations, and it can be seen by the user in the form of output devices like monitor. Logical instructions. The logical instructions are compare and or XOR operations. We can compare the accumulated data with the registers, compare the data with the memory, and operation is nothing but we can perform AND operations with the accumulator and with the register. We can perform AND operation with accumulator with the memory address, and the result is also stored in the accumulator. XOR operations. XOR operation with memory, XOR operation with register in and XOR, or we all in all these three things we can store the data. That is the result. It will be stored in the accumulator. In the compare. In the compare, we can see carry flag and zero flags are affected, and the magnetic hard disk, how the disk can be mechanical structure, how actually this part is called a rectangle, how the disk can be rotated in the read write head positions, and then it is organization of disk. The disk consists of sectors, tracks. If in one sector consists of more than one track, the both sectors and track both can be surface area can be combined. It can sector and track can be combined. It form a surface area. And then the disk controller, the processor and main memory can be connected through the system bus to the disk controller. The disk controller consists of disk drives. The disk controller mainly use the disk controller is for to erasing the disk drives can perform the operations like erasing the data, storing the data, or performing the manipulations. And the disk controller is used to control the disk drives, and the processor and main memory for performing the operations. If we are having any operations, then it can it can sends to the processor. The processor thinks that whether it is a ALU operations or it can ALU operations, then it can gives to the automatic logical unit. Then it can perform the operation, and again it can send to the disk and main memory. If the operation can require any memory or any address, then it can send to the main memory. Then it can perform the operation. It can next send back to the disk controller. Actually, the memory consists of primary memory, secondary memory, registers, cache memory, everything. The primary memory is used for storing the small amount of data, and the secondary memory is used for storing the large amount of data. But in the secondary memory, we can't write the data; we can only read the data. In the primary memory, is called random access memory. Registers is used for accessing the data very fastly. For the purpose, we are storing the data in registers. If you are in the second primary memory also, we can access the data, but it can take some time compared to the registers are very fast compared to primary memory. So for that purpose, we can store the very efficient data very frequently. Using data we can store in the registers, and we can retrieve the data with help of register for increasing the performance, for increasing efficiency. For the purpose, we are storing the data in registers. Mm, and then finally we can discuss about CD technology, how the DVDs can be how the DVD can CD technology is nothing but the DVDs. All the things in the DVD, how the data can be stored. In polycarbonate, here we are having polycarbonate plastic, aluminium, acrylic, label. The polycarbonate plastic is in the top bottom position. Polycarbonate plastic is in the top position, and the label is in the bottom position. Here the polycarbonate plastic is a shining pot. Actually it is not a glass, it is a polycarbonate plastic. Aluminium is used mainly because it can actually data can be stored in the aluminium in the form of bits and labels. And label is used for storing. Label is used for writing the data in the form of we can see in the DVDs. We can and find out some songs name or movies name or other everything. It can be placed in the form of in the place of labels. Hello.
Yeah, thanks, Anisa.
Thank you, sir.
So,
Hi guys.
go ahead, Preeti.
Is there any issue? Is there any doubt so far till now?
Guys, are you facing any queries?
Thanks, Anisha and Pawan, for the very good presentation. Actually, you presented very well.
Yeah, from my side, so thank you, Pawan and Anisa. So you have taken a lot of time to prepare all the slides and explain. So much appreciated, and it is very useful for the students. So it will be available on the YouTube, so students can go through and refer. If they have any questions, they'll come back to Lighthouse team. Thank you so much for your time today. Thank you, team, for organizing this. And thank you, students, for attending.
Thank you, Anisha and Pawan, for sharing your knowledge according to the topics. Thank you, Lighthouse team, for your support. And Jani sir, mainly, thank you for your support to the students
Pleasure is mine. Thank you.
by making such a bridge. Thank you, guys, all of you. Thank you.
Thank you, everyone. Bye bye.
Sir, can I close the section?
Yes, you can close the session. Thank you. Bye.
Thank you, sir.